Hello everyone, and welcome back to another GIS lecture video. And in this lecture video, I want to continue our discussion on raster data by focusing in on an individual pixel and talking about what is probably the most important property of raster data when you're thinking about using it for an application or when you're trying to develop a raster data set for a given application. And that is going to be something called the cell size. Oops. And we'll talk about this again in remote sensing, you'll see this sometimes called the spatial resolution. Okay. And so if we think about, right, this is a single pixel with some value in it. Right, a single pixel with some value in it. And we said before, right, that the idea of raster data is that we take an area and we break it up into evenly sized grid cells. And in each grid cell, we estimate whatever we're trying to measure for that area. So we've kind of ignored a big question, right? How much area does a pixel? I'm sorry, I'm a remote sensing scientist by training, so I always use pixel. But again, pixel and cell or grid cell are interchangeable. Represent. Right? Does this pixel represent 1 kilometer? Right? Does it represent 1 meter? Does it represent maybe a foot? Does it represent maybe 2 centimeters? Right? Who knows? We haven't said anything. We don't know, right? We haven't made that assertion yet. It's a very important question to know, right? If this pixel covers an area and this value represents that area, how big of an area are we talking about? Well, this question is addressed by the value known as cell size. Okay? So this question right here, this how much area does a pixel represent, this is cell size. I'm going to put ish. Cell size ish. And the reason I'm putting the ish here and the reason why I'm underlining ish is because it gives us an indication of how much area it represents. Right? What cell size actually measures is the length from one edge of the pixel. Right? This distance from here to here, this is the definition of cell size. Right? So to be verbose about it, right? Cell size is the length of one edge of a cell. That's why it's called cell size, right? So this length, so from here to here, is the cell size, right? So if we wanted to know how much area this pixel represents, right? Think about the area of a square, right? The area would be cell size squared, right? Okay, so hopefully that makes sense. This is a pretty straightforward definition, right? But let's talk about why cell size matters, or a visual example of what happens and why cell size matters, right? So let's say that we have a pixel. Actually, let me do this in a different color. Let's say we have this orange pixel right here. Right, so this is pixel in one raster. right? I'm not going to draw its value, but just remember that this is going to have a value inside of it that represents all of the area that is covered by this 1 pixel. Okay? And let's just say that the spatial resolution or the cell size for this particular example is 9 meters. Okay? So that means, right, that the length along one edge of the cell is 9 meters. So the area of this would be, right, 81 meters squared, because I squared the cell size. Okay. Now, let's say that we have another raster, right? Another raster that covers the same area with a spatial resolution of 3 meters. Okay? So another raster over same area has a spatial resolution of 3 meters, right? Or an area of 9 meters squared. Okay. How would this raster compare to this raster? So keep in mind, this is 1 pixel from our 9 meter spatial resolution raster. Well, how would that compare? So this raster, right, if we assume that it starts here, let's say this is the lower rightmost pixel. So if we start here in the lower right corner, right, a 3 meter spatial resolution raster, right, would be something like this. Right? Because, right, this distance right here, let me do this in a slightly different color. Right, this distance right here, right, that's 3 meters. So 3 plus 3 plus 3 is 9. Okay? So why did I go through why did I bother with this, right? Why am I bothering to hammer home this point? Right? A 9 meter spatial resolution can fit 9 3 meter spatial resolution cells inside of it. Because think about for a second, taking this a sort of wide, broad step back for a second, and think about again the concept that this value in this pixel represents this whole area. And think about rainfall as a good example, or elevation as a good example, right? If we have a 9 meter pixel size, right, we're assuming that all of these smaller pixels are the same value, right? Let me elucidate this a little bit further here, actually. Okay, let's actually put some values in here. Right, let's say this has a value of 12 inches of rain. Right. So we're saying that in this 9 by 9 area, right, 12 inches of rain. But you might be like, okay, well, where within, right, this cell did that 12 inches of rain occur? How is it distributed? Well, that's where having a higher spatial resolution raster comes in, right? Because if we cover that exact same area with a higher spatial resolution, right, we now have 9 pixels covering the same area of 1 pixel because this is a 3 meter, right? And so maybe we find out, oh crap, right? There's actually no rain here, right? 6, 5, and 1, right? It turns out that most of this rainfall came from these 2 areas here. Hopefully this makes sense and gets the point across, right? That the finer the spatial resolution, right? The smaller the cell size, the more specific your measurement is to a particular area. Okay, let me write that down. Right, the smaller the spatial resolution or cell size, right, the more specific the value is to a smaller area. Now, I'm not saying it's more accurate. I'm saying it's more specific, right? We had 12 inches of rain for this 9x9 area, right? We're now saying, well, 6 of that came from this 3x3 area here. I'm not saying that these are accurate, right? These may be completely wrong relative to the real world, but this is more specific. Right? This is more specific to this area, right? So hopefully this makes sense. Take a minute, think through this idea of spatial resolution. Think through what it means in terms of the length of one side versus area, and think through what happens conceptually as we change cell size. So as always, if you have any questions, please reach out. Thank you.